Hello guys, this is Netra P Chand. Welcome to my mathematics class. Let's see the today's topic. Today's topic is binomial coefficients. Now I'm going to prove some important properties of binomial coefficients. So firstly, let's know what is the binomial coefficients. So binomial coefficient, the coefficients, okay, this, and so on. This in the expansion of this are known as binomial coefficients. All right, are known as binomial coefficient. Properties of binomial coefficients in the expansion of 1 plus x raised to power n, the sum of the binomial coefficients is 2 raised to power n. Number one, important one, I've taken, that is, we can write down, this one nc0 plus nc1 plus dot 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 plus ncn is equal to 2 raised to power n. For simplicity, this one we can write down, c0, we can ignore n plus C1 plus C2 plus dot dot plus Cn is equal to 2 raised to power n. Okay, C1, C0 means NC0, C1 means NC1. It's understood thing in the expansion of 1 plus x raised to power n. These are the coefficients, right? Okay, sum of the coefficients that is sum of the binomial coefficients is 2 raised to power n. The second one, in the expansion 1 plus x raised to power n, the sum of the odd terms is equal to the sum of the coefficients of the even terms, and each is equal to 2 raised to power n minus 1. Okay, sum of the odd terms, coefficients of odd terms here. Here I forgot to write down, the sum of the coefficients of odd terms here, sum of the coefficients of odd terms is equal to the sum of the coefficients of even terms, and each is equal to 2 raised to power n minus 1. That is C0 plus C2 plus C4 plus dot dot is equal to C1 plus C3 plus C5 plus dot dot is equal to 2 raised to power n minus 1. I'm going to prove these two properties. These two properties are very, very important. So let's try to prove first one. For C0 plus C1 plus C2, I'm going to prove this one. See, we have 1 plus x raised to power n is equal to 1 plus x raised to power n is equal to, you can expand like this way, c and comma 0, okay, x raised to power 0 and plus c, and because 1, so we can ignore directly, we can write down this one. So actually, we write down c of n comma 0 into 1 and minus 0 x raised to power 0, like this was c of n comma 1 and 1 raised to power n minus 1 x raised to power 1. This will be expand, as you know, the 1 raised to power, right, power of 1, is equal to 1. That's why I have not written here, so directly I am going to write down c of n comma 1 here, x plus c of n comma 2 x square plus dot 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 plus finally here I'm going to write down, plus here because lack of space, so c of n comma n x raised to power n. This is the expanded form of 1 plus x raised to power n. Okay, so I don't think you have a problem. Definitely you might have seen my all your videos on binomial theorem. Okay, so you can write down very easily. Now this one, same thing, I can write down, c and c0 simply, and is understood in all coefficients and is same. So only in terms of r you can write down, means c0 c1, here x is 1, simply c1x plus c2 x square plus cn, and dot dot plus, and here cn x raised to power, and it's understood thing, listen to me here, cn0, denoted by c0, C of n comma 1 is denoted by C1 for simplicity, because in this case n is understood. Alright, C0 means n, C0 we have to understand this. Alright. uh, or here 1 plus x raised to power n. So I'm going to prove sum of the binomial coefficients is equal to 2 raised to power n. Alright, in easy way we can prove, not so difficult, very easy one topic here today I've taken. Putting x is equal to 1, we get, if we put x is equal to 1 here, we will get, okay, 1 plus 1 raised to power n is equal to c0 plus c1 times x means 1 only. Here 1 square is 1, so c2 plus dot dot and plus here cn we can write down, right? Or you will get here c0 plus c1 plus c2 plus dot dot plus cn is equal to 1 plus 1 to 2 raised to power n. Okay, so we have proved the first property on binomial coefficients, right? The first property of a binomial coefficients. So one of the important properties of the binomial coefficients, very easy to prove also, right? Now you can just memorize, okay, c0 plus c1 plus c2 plus dot dot plus cn is equal to 2 raised to power n. You can note down also here, because of C0, okay, C1 plus C2 plus dot dot Cn is equal to 2 raised to power. As we know, and C0 is 1. Instead of n, there is any number. C0 means 1, okay, in all cases, okay, right? Yeah, 1 always, okay. C0 means always 1. It doesn't matter, okay, where there is a n or any other number, any other natural number, it doesn't matter. C1 plus C2 plus dot dot Cn is equal to 2 raised to power. And or you may write down C1 plus C2 plus C3 plus dot 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 and Cn is equal to 2 raised to power n minus 1. Minus 1 is not in power here. 2n subtract, okay? 2n minus 1 here. You can memorize this also, right? Okay, so actually this is the property. From property we have derived this one, right? Sum of the binomial coefficients is equal to 2 raised to power n, and combination of right, sum of the, okay, coefficients from 1 to n, right, is equal to 2 raised to power n minus 1. Okay, so I don't think now you have a problem, right? You understood, and this one also understood, right? So very easy. Now I'm going to prove the second one. In second, we have to prove in the expansion 1 plus x raised to power n, the sum of the coefficients of odd terms, here coefficients of odd terms is equal to the sum of the coefficients of even terms and is equal to 2 raised to power n minus 1, that is c0 plus c2 plus c4 plus dot dot is equal to c1 plus c3 plus c5 plus dot dot is equal to 2 raised to power n minus 1. Let's prove. Second, very easy. I think proofs are written. Alright, no problem. We have 1 plus x raised to power n is equal to c0 plus c1x plus c2x square plus c3x cube plus dot dot, and here cn x raised to power n. Okay, this is the expanded form of 1 plus x raised to power, and now I'm going to use, instead of x minus 1, putting x is equal to minus 1, we get 1 minus 1 raised to power n is equal to c0 here plus c1 minus 1. I'm not writing directly, otherwise you may have in confusion. C2 minus 1 raised to power 2, C3 minus 1 raised to power 3 dot dot plus Cn minus 1 raised to power n, right? Okay, here you are going to get 0 is equal to C0 minus C1 plus C2 minus C3 plus dot dot and plus minus 1 raised to power n, and here Cn. Okay, now you may write down like this way, or C0, okay, 0 here on the left hand side you have a 0 is equal to, now you can just collect positive 1 coefficients and then collect negative 1 coefficients in one bracket. Yes, C0 or C0 plus positive which C2 plus C4 plus so on. So definitely, okay, here you will have your C of 2, and you can say, right? Okay, so this way, and plus, so minus, okay, you can take just minus common C1 plus C3, okay, and plus and C5 plus dot dot, right? Okay, and here you will have, okay, C raised to power 2n minus 1, okay, 2n minus 1 you may write down, okay, otherwise, okay, no need, okay, because here in properties we have not written, so you can also buy, no need to write down, okay, just it's an understood thing, 2n terms it will go, and this will also go to 2n terms, right? Here, or you may write down, okay, here 0 here, so okay, so we can write down, okay, C0 plus C2 plus C4 plus dot dot is equal to, right, I'm just, okay, and this transmitting 1 on left hand side, you will get, okay, here C1 plus C3 plus C5 plus dot dot. Okay, now I also think you have a problem, so okay, now write down here 1, we know what we know, okay, C1 plus C2 plus C3 plus dot dot and plus Cn is equal to C0 also plus is equal to 2 raised to power n. So already, okay, we have proved some of the binomial coefficients is equal to 2 raised to power n, and here you will write in C0 plus C2 plus C4 plus dot dot and plus, and you can collect, okay, another one, C1 plus C3 plus C5 and dot dot is equal to 2 raised to power n. Using, okay, first result, you can write down, okay, C0 plus C2 plus C4 plus dot dot and plus here also you can write C0 C2 plus C4 plus dot dot is equal to 2 raised to power n, because, okay, they are equal to each other, in this equal to this, that's why instead of this I have written this one, right? Here you may write down, okay, using this result, or you will get here 2 C0 plus C2 plus C4 plus dot dot is equal to 2 raised to power n. So easy steps here, or you will get, okay, C0 plus C2 plus C4 plus dot dot is equal to 2 raised to power n by 2 divided by 2, and you will, okay, divided by 2 and is equal, or you will get here C0 plus C2 plus C4 plus dot dot is equal to raised to power n minus 1. Okay, now from first we can, they are equal, we can write down here we can write down so therefore finally, okay, C0, because they are equal to each other, and C0 plus C2 plus C4 plus dot dot is equal to C1 plus C3 plus C5 plus dot dot is equal to 2 raised to power n minus 1. This way we can prove. I don't so think now you have a problem. You have to memorize both results, right? Number one, once again, let me repeat, okay, C0 plus C1 plus C2 plus dot dot is equal to 2 raised to power n. Another one, okay, C0 plus C2 plus C4 plus dot dot is equal to C1 plus C3 plus C5 plus dot dot is equal to 2 raised to power n minus 1. Okay, so let me repeat again. Okay, number one property, sum of, right, binomial coefficients is equal to, in the expansion of 1 plus x raised to power n, sum of the binomial coefficients is equal to 2 raised to power n. Second property, in the expansion of 1 plus x raised to power n, sum of the coefficients of odd terms, sum of the binomial coefficients of odd term is equal to sum of the binomial coefficients of even terms, and each is equal to 2 raised to power n minus 1. Right? 2 raised to power n minus 1. So I also think you have a problem. If you have a problem, you can write down in comment box. Okay, thank you very much for watching my video. Bye bye.